At 5:45 in the morning on Monday, July 20th, the ground beneath the Caribbean Sea near Tobago shifted, and within minutes, earthquake monitoring maps across multiple independent agencies lit up with reports from across the region. A magnitude 5.1 earthquake struck CK, roughly 20 kilometers northeast of Scarborough, Tobago, felt as far away as Port of Spain, Trinidad, more than 100 kilometers to the southwest. Just over an hour later, at 6:55 in the morning, a second earthquake struck nearby, this one measured at magnitude 5.0. No injuries, no structural damage, no tsunami warning. On the surface, it looked like a quiet, uneventful morning that ended without incident. But scientists studying this exact stretch of the Caribbean seafloor were watching for a very different reason, because these two earthquakes struck on the same extended plate boundary system that, less than 4 weeks earlier, produced a double T of earthquakes in Venezuela that has now killed more than 5,500 people. This is the story of what actually shifted beneath Tobago this week, why researchers have already identified major segments of this same fault system as locked and capable of producing an earthquake far larger than anything felt this week, and what that means for the millions of people living along this stretch of the Caribbean. No hype, no exaggeration, just what actually happened and what the data behind it means. Drop a comment and tell me if you are in Trinidad, Tobago, or anywhere in the southeastern Caribbean, and whether you felt either of Monday's earthquakes yourself. I read every one of these. If you want grounded science coverage instead of panic headlines, subscribe. It is free, and a like helps this reach people who need to understand this. Let us go for 5,000 likes on this one. Thank you. Now let us get into it. To understand why 2 moderate earthquakes near Tobago mattered enough to catch scientists' attention, you first have to understand the specific piece of geology sitting underneath the entire region. Trinidad and Tobago sit directly on the boundary between the Caribbean and South American tectonic plates, part of an extended fault system geologists call the Bocano El Pilar system, which runs for more than 1,300 kilometers, starting in the Venezuelan Andes and stretching all the way east past Trinidad. Along the way, the strain built up by the Caribbean plate's steady eastward motion, roughly 20 millimeters a year relative to South America, gets distributed across a whole family of individual faults rather than releasing along any single one. In Venezuela, that strain moves along the San Sebastian fault, slipping at roughly 16 millimeters a year, and the La Victoria fault nearby, then transfers onto the El Pilar fault itself, which researchers have measured accommodating slip at close to 19 millimeters a year in northeastern Venezuela. From there, research has confirmed the slip continues eastward through the Los Bajos fault and onto the Warm Springs fault closer to Trinidad, eventually reaching a cluster of faults directly beneath Trinidad and Tobago, known as the Central Range Fault, which researchers moves at around 14.5 millimeters a year, along with the smaller South Coast Fault and Sub-Tobago Terrain Fault, each estimated at around 3 millimeters a year. This entire chain forms one continuous, compressional, right lateral strike slip boundary, running the length of the Caribbean South American plate margin, which means an earthquake anywhere along. It is, geologically speaking, part of the same overall system as an earthquake anywhere else along it. Monday's 2 earthquakes near Tobago struck at moderate depths, between roughly 59 and 73 kilometers, depending on which monitoring agency's estimate you use, which is exactly why they caused no damage despite being felt so widely. Earthquakes at that depth release their energy far enough underground that the shaking at the surface, while noticeable, rarely reaches destructive levels, since the surrounding rock has more distance to absorb and dissipate the seismic waves before they ever reach a building's foundation. Shallow earthquakes, by contrast, those occurring in the top few kilometers of crust, account for roughly 75% of all seismic energy released on Earth, and are responsible for the overwhelming majority of earthquake fatalities worldwide, precisely because their energy has nowhere to dissipate before reaching the surface. That distinction matters enormously for understanding both what happened this week and what happened last month. On June 24th, just 100 miles west of Caracas, Venezuela, 2 massive earthquakes struck within 39 seconds of each other along this same extended fault system, a rare seismic doublet with magnitudes of 7.2 and 7.5, both centered in Veroes municipality near San Felipe. Unlike Monday's earthquakes near Tobago, these struck at shallow depths of just 20 and 10 kilometers. The result was catastrophic. More than 80% of buildings in La Guaira state collapsed. Across the wider region, more than 2,500 structures were confirmed destroyed or damaged, with later estimates from engineering assessment teams putting the number of damaged or destroyed buildings closer to 60,000 once outlying areas were fully surveyed. As of the most recent tallies, more than 5,500 people have been confirmed dead, with more than 16,700 injured and tens of thousands still reported missing. It was the strongest earthquake to strike Venezuela since the year 1900. More than 1,000 aftershocks followed in the weeks after, including one strong enough to collapse a bridge in La Guaira days after the initial disaster. The United States Geological Survey's own damage estimate system had initially warned the death toll could climb past 10,000. Humanitarian officials estimated that up to 6.8 million people across the country could ultimately need some form of relief assistance, including hundreds of thousands of children. This is the part that should genuinely change how you think about Monday's quiet, damage-free morning near Tobago. Research published in the journal Tectonics in 2021 specifically modeled how strain is locked versus creeping along different segments of this exact plate boundary, using a combination of global positioning system data and satellite radar. The researchers found that significant portions of the Caribbean-South American plate boundary are locked, meaning the two plates are jammed against each other rather than sliding freely, silently accumulating stress rather than releasing it in small, harmless increments. Separate paleoseismology work specifically on the Central Range Fault, one of the fault segments running directly beneath Trinidad, found that it cuts through sediment less than 5,000 years old while being capped by sediment only around 550 years old, evidence consistent with the fault having locked and ruptured at least once within roughly the last 2,000 years. Combined, this body of research has led scientists studying the region to conclude that a significant locked portion of this boundary system is theoretically capable of producing an earthquake as large as magnitude 8, an order of magnitude more energy than anything that struck near Tobago this week. It is important to be precise here, because the science genuinely is more nuanced than a single alarming number. Not every segment of this fault system behaves the same way. The same body of research that identified locked segments capable of a magnitude 8. Rupture also found that certain faults further east, including portions closer to Trinidad and Tobago specifically, show signs of aseismic creep, quietly releasing some of their strain without producing large earthquakes at all, in a similar pattern to what researchers have separately documented on other Caribbean faults, including the one running through Haiti. Determining exactly where the boundary sits between a fault that is safely creeping and one that is dangerously locked requires exactly the kind of combined satellite, radar, and ground-based positioning data that took researchers years to assemble for the 2021 tectonic study in the first place. And even then, the resulting picture is a set of probabilities and estimated locking depths rather than a simple yes or no answer for any single fault segment. Untangling exactly which specific segments beneath Trinidad and Tobago are creeping harmlessly and which remain locked and loaded is still active, ongoing research, which is exactly why Monday's earthquakes, harmless as they were on their own, matter enough for seismologists to study closely rather than dismiss. None of this is unfamiliar territory for this specific stretch of ocean either. The strongest earthquake ever recorded near Tobago struck on March 19, 1953, a magnitude 7.3, event roughly 300 kilometers north of Scarborough at a depth of 129 kilometers, a magnitude 5.8. Earthquake struck just 33 kilometers west of Scarborough as recently as December of 2016. An earthquake in April of 1997 specifically reactivated the boundary between the Tobago terrain and continental South America, the same structural feature partially responsible for this week's activity. Trinidad and Tobago has recorded at least 14 earthquakes above magnitude 6 since the year 1900, a rate that works out to roughly 1 every 5 to 10 years, and the region logs an average of 26 earthquakes of magnitude 4 or higher every single year within 300 kilometers of Tobago, or about 1 every 2 weeks. Seismologists at the University of the West Indies Seismic Research Center, the agency responsible for monitoring this exact region, actively track this pattern year-round and specifically encourage residents who feel any tremor to submit reports through their public feedback portal, precisely because that kind of citizen reporting helps researchers refine exactly which fault segments produced a given event. Monday's pair of earthquakes, in other words, were not an anomaly. They were this fault system doing what it does on a fairly routine basis, which is exactly what makes distinguishing routine background activity from a genuine warning sign one of the harder problems facing seismologists working in this specific region. So what does all of this actually mean for you, especially if you live anywhere in Trinidad, Tobago, or the wider southeastern Caribbean? It does not mean Monday's earthquakes are a confirmed precursor to an imminent magnitude 8 rupture, and no seismologist studying this fault system has made that specific claim. What the science does show clearly is that this region sits directly on an active, structurally continuous plate boundary that, 1 month ago on its western end, produced one of the deadliest earthquakes Venezuela has ever recorded, and that peer-reviewed research has already identified real locked segments of that same boundary capable of an equally catastrophic rupture. If you live in this region, the practical takeaway echoed by seismic hazard researchers across the Caribbean is the same one that applies to any actively deforming plate boundary. Building codes, structural retrofitting, and household earthquake preparedness matter most precisely during the quiet years between events, not after a headline-making earthquake has already struck. Venezuela's death toll was driven as much by construction quality as by the size of the earthquake itself, a lesson engineers across the wider Caribbean are already citing when discussing what a similarly sized rupture nearer to Trinidad and Tobago could look like, depending on how buildings there have been. Reinforced, having a household earthquake plan, knowing which parts of a home offer the most protection during shaking, and understanding that a moderate depth earthquake causing no damage today says nothing about whether the next one on this same system will be shallow enough to cause real harm are all far more useful steps to take. Now than waiting to see whether Monday's earthquakes turn out to have been a meaningful precursor. The honest, grounded summary is this. 2 moderate, non-damaging earthquakes struck near Tobago on the morning of July 20th, registering as high as magnitude 5.4 depending on the reporting agency, both at a depth deep enough to prevent any real damage. They occurred on the same continuous 1,300-kilometer plate boundary system that produced a catastrophic seismic doublet in Venezuela less than a month earlier, an event that has now killed more than 5,500 people. Peer-reviewed research has confirmed that significant portions of this boundary system remain locked and are theoretically capable of an earthquake many times more powerful than anything felt this week, even as other segments closer to Trinidad and Tobago appear to be quietly releasing some of their own strain through creep. Monday's earthquakes fit within this region's well-documented decades-long pattern of moderate seismic activity, and no scientist has linked them directly to any specific, imminent, larger event. What they have done is put a very real, very active fault system back on the map, in the most literal sense, for anyone paying attention. We are going to keep tracking this as new activity and new research come in, sourced the same way we did today, straight from the University of the West Indies Seismic Research Center, the United States Geological Survey, and the peer-reviewed research actually studying this plate boundary, not recycled headlines. Subscribe so you do not miss the next update, because a fault system this active rarely stays quiet in the data for long. And leave that comment below. Tell me where you are watching from and whether you have ever felt an earthquake. In the Caribbean yourself. Because behind every one of these numbers is a family in Scarborough who felt their house shake before sunrise and went back to sleep once it passed. A family in La Guaira who was nowhere near as fortunate 1 month earlier, rebuilding from a disaster that reshaped their entire coastline in under a minute, and a fault line running quietly beneath one of the most beautiful stretches of ocean on the planet, storing pressure at its own pace, on its own schedule, regardless of who happens to be watching. 5,000 likes on this one. Let us go. See you in the next one.